is defined, is given by, let us write this, okay, P bar equal to summation QI RI bar. So this is the definition of dipole moment for a set of charges about the origin. Next, let us find the potential due to many point charges at a faraway point. Now, generally we can do this. What we can do is, suppose this is Q1, Q2, so on, some Qi, let us say this is. We can do KQ1 by distance between these two, KQ2 by distance between the two, and so on. The position vectors of each of these charges is known. The position vector of this general point is also known. Okay. So if we try to do that, we get a very complicated result. Rather, using the dipole moment of this configuration, let us see how it becomes very easy to find out. And this dipole moment formula is what was given in the JEE Mains 2026. Okay. So let us see the simple formula to find the potential at a general point. So suppose the general point is at R. Okay. And this a charge Qi is at some Ri, let us say. Okay. And this is from this charge to this point is some R dash, let us say. And we know that we need to find out at a very far away point. That means this R is very much greater than Ri. Okay. See, what is, I'll just write down here, what is R? Position vector where potential has to be found. Where potential to be found. Okay. What is Ri? Position vector of each charge. Okay. So just this position vector is something like this. Anyways, we are using the magnitude here. Okay. And so suppose, let us say this is theta. So what can I write here? Tell me. If I need to find the potential due to all these point charges, potential equal to KQ1 by R1 plus KQ2 by R2, so on. So I can write this whole sum as summation K QI divided by R dash. R dash means, for this is it as R dash, let us say R1 dash, R2 dash. This is Ri dash, okay. KQI by Ri dash is the summation. Now, what we can write, this Ri dash, this is Ri dash, okay. Now I want everything in terms of R and theta. So I will just see, we know that this is very large compared to this. So to find what is this in terms of, I can directly draw perpendicular here. Okay. And now this is these both sides are equal. So what is this? This is Ri cos theta. So what I can say is this R equal to Ri dash plus Ri cos theta. Directly I can write this. Okay. And this Ri dash, see here we have 1 by Ri dash, no? So we'll just write it in these terms. What is Ri dash? Equal to R minus Ri cos theta. Okay. So if I take this R common, what will I get? Ri dash equal to R into 1 minus Ri by R cos theta. See, I require Ri dash, inverse I require 1 by R dash. So if I take this inverse, this one I'll get it as 1 by R, a minus 1 here, no? So that will be, it will become 1 plus Ri by R cos theta. Okay. Now we'll put this here. So the potential becomes summation kqi into 1 by r plus ri by r square cos theta. You see the expression now, how it comes out to be. It comes out to a very nice expression. V equal to summation kqi by r plus summation kqi ri cos theta divided by r square. Okay, so V equal to, see, k and r is the same. See, r is what? R is the position vector of this point, the general point P, and that r is going to be the same. It is not going to change. Okay, so I'll get this as k summation k. What is summation k? K q total divided by r plus, now you see this summation qi ri cos theta. Okay, what is this summation qi ri? Tell me. That is the dipole moment. Okay, so qi ri, summation qi ri is a dipole moment. Cos theta is what? Angle between the dipole moment and this r vector. So can I write this as k summation qi ri is p bar dot r cap, okay, divided by r square. So this p bar consists of summation q1 r1 plus q2 r2 bar plus q3 r3 bar, and r1 bar q1 r1 bar dot r cap will be q1 r1 cos theta 1, q2 r2 cos theta 2, and so on and so forth. Okay, so see, we are getting the potential in two parts. One is the potential due to the dipoles, and third is the potential due to the total charge, which is the monopole, we can say. Okay, so if suppose there were only dipoles, suppose there are many dipoles placed at different points, and you had to find the potential, what will you do? You will take one dipole. From that dipole you'll see the distance, and you'll find the potential there. From the second dipole you'll find the potential there, and so on and so forth. Rather, if you know that there are many scattered dipoles, okay, the first term will become what? In a dipole there is only equal and opposite charge, so this first term becomes 0 anyways, and the second term remains as is, that we found in potential due to dipole in the last part, k p bar dot r cap divided by r square. And what is this p bar here? P bar here is summation of qi r i. Okay,